In section 4.2, we're going to talk about some theorems related to the angles of a triangle. And the first theorem we're going to look at is called the interior angle theorem. The interior angles in a triangle are the ones that, probably you can guess this, but are on the inside of the triangle. So if we look at that triangle over to the right of the blue box there, we see three angles inside of that triangle labeled 1, 2, and 3. And so if you added up that red angle, the green angle, and the black angle, they would add up to 180 degrees. And that's true of any kind of triangle that you have. It doesn't matter what it looks like, the interior angles will add up to 180 degrees. So if we go to example 1, it says solve for x. So in example 1a, they don't exactly use an x, they use a question mark, so let's change that to an x. If we wanted to solve for x, we would just add up the three things that we see. We see an x plus a 40 plus an 85, and we would set it equal to 180 degrees. Because again, the inside of a triangle always adds to 180 degrees. So we'll have x plus 125 equals 180. We'll subtract 125 from both sides. And we'll get x equals 55 degrees. So the missing angle in this triangle must be 55 degrees. Another way the problem could look is like in example 1b, where instead of two numbers like we had in example 1a, we just had numbers in two of the spots, we might have an expression, right? So 5x plus 6 is an expression. We don't just have to have numbers. And so it's still the same rule. The inside angles of the triangle will add to 180 degrees. So 5x plus 6 is trying to describe one of the angles, plus the 82 is the second angle, plus 52 degrees is the third angle. So we're adding up all three angles and setting it equal to 180 degrees. So if we add up those numbers, let's combine our like terms first. So if we have 5x plus all those numbers, that would make 5x plus 140 equals 180. Subtract 140 from both sides. We'll get 5x equals 40, and then divide by 5, and you'll finally solve for x. If we divide by 5, our x will be 8. So again, we're just using that rule that on the inside of a triangle, the three angles will add up to 180 degrees. All right, now in letter C, be careful with that. Remember that you have to add up all three angles. So one of the angles is 6x minus 8. The other angle is 6x plus 2. But don't forget about the third angle. The third angle is that red box in the corner. Remember that that is 90 degrees. So you have to include all three angles when you add them up to 180. All right, so don't forget about the 90. So we have 12x, and we have plus 84. If we add up our negative 8, our 2, and our 90, that is going to be equal to 180. Subtract 84 from both sides, and we'll get 12x equals 96. And then if we divide by 12, didn't realize this happened, but we got another 8. So I guess we're going to get 8 twice this time in example B and in example C. So our x is equal to 8 here also. Now I didn't ask you to plug it in anywhere, but I could have. I could have asked you then to go plug that 8 in and figure out the missing angles in the triangle. But in this problem, all it said in the directions was to solve for x. So we're actually done once we solve for x. All right, so the interior angles in a triangle always add to 180 degrees no matter what the triangle looks like. All right, we're going to do one more theorem in this set of notes. We're going to do what's called the exterior angle theorem. Now, an exterior angle happens on the outside of the triangle. So the interior angles 1, 2, and 3 added up to 180 degrees. But let's talk about an exterior angle. An exterior angle happens when they extend one of the sides of the triangle. So you can see right here that I'm highlighting in yellow. That's an extension of the triangle. When they do that, when they extend one of the sides, it's so that they can create what's called an exterior angle. So angle 4 in that picture is considered an exterior angle. And the theorem says the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. And so let's talk about that word remote interior, right? What's remote interior angles? Remote interior angles, the word remote means not next to. So the two angles that are not next to angle 4 are angles 1 and 2. So in our picture up above, angle 4 is considered an exterior angle, and the remote interior angles are considered angles 1 and 2. So notice in the theorem, we don't use angle 3 at all. So angle 4 will be equal to the measures of angle 1 and 2, and angle 3 doesn't even matter. All right, so let's look at our pictures and see how this is going to work. It says again, solve for x. So in that first picture, let's change that question mark to an x. They like to use question marks sometimes, but I like to see x's instead. All right, so if we were going to solve for x, that's again called an exterior angle. The exterior angle, which is x, is equal to the sum of the remote interiors. So 97 plus 28 will give me that exterior angle, because the 97 and the 28-degree angle are not next to that x. So if we add up 97 plus 28, our x will be equal to 125 degrees. All right. Now don't be confused when they move the x to the inside of the triangle, right? In example 2b, that question mark, which I'm going to change to an x, is on the inside of the triangle, but that remote angle, which is 142 degrees, so 142 equals, remember your exterior angle, if we look back up above, our exterior angle is equal to the sum of the remote interiors. So 142 will be equal to x plus 40, because x and the 40 are considered remote interiors. So if we just subtract 40 off of both sides for this one, we end up getting 102 equals x. So in this case, our x is equal to 102 degrees. So it's the same idea, it's just that the unknown quantity was an exterior angle in example 2a, but it was an interior angle in 2b. All right, finally in C, everything that's labeled, if we look at each of the things that's labeled, we're going to see the first thing that I'm going to highlight here is an exterior angle because it's outside of the triangle. And then the next things I'm going to highlight in green are our remote interiors. So our exterior angle, which is -5 plus 11x, will be equal to the sum of the remote interiors. So it'll be equal to 36 plus 5x plus 1. All right. So just remember how to solve equations. We always combine like terms first. So on the left side, we don't have to do anything, but on the right side, we have to combine the 36 and the 1. So we'll get 5x plus 37. And now subtract your variables. So I'm going to subtract 5x so that it can join the 11x on the other side. And we get -5 plus 6x equals 37. And then we're going to add 5 because we're trying to isolate our variable. So if we add 5, we get 6x equals 42. And then finally, if you divide by 6, your x is equal to 7. All right, so that's the exterior angles theorem. If you add up the two remote interiors, it will be equal to the exterior.